Okay, so in this third video lecture, we are going to solve some problems on circuit connections. This is our first circuit. We have three resistors. They are in series, thankfully, and we need to find the total resistance. Or in other words, if we plan on replacing these three resistors with a single one, what would be the value of that resistor so that it would have the same effect as the three original resistors? So again, formula for total resistance in series connection is really easy. You just need to add the resistances. That's 17 plus 12 plus 11. The answer is 40 ohms. So the effect would be the same if you replace it with a single resistor with a rating of 40 ohms. Okay, now we need to find how much current is passing through each resistors. Remember that when the resistors are connected in series, the current is the same all throughout. You can also draw the direction of the current, and I1 is the current passing through resistor 1, and so on and so forth, I2 and I3. If this is the case, if I total, the current passing through the whole circuit is just the same as the current passing through resistor 1 and 2 and 3, we can just compute for the total current, right? This is coming from the Ohm's law, voltage over resistance. We're also given with the total voltage here. Total resistance is what we computed from a while ago. So 60 over 40, that's 1.5 amperes. That's also the current passing through here, R1, through R2, and through R3. Remember that this is only true for series connection. Okay, we are also going to compute for the voltage drops, or how much voltage is lost when they pass through the resistors. Okay, so the formula is I times R, still coming from the Ohm's law. The resistances are given already. The current is, we computed that from a while ago. They are all the same for I1, I2, and I3. Let's put some subscripts here because the voltage drops are going to be different since we have different ratings of resistances. So the voltage drop as the current passes through R1 is computed this way. So the total current, or the current through I1 is, through R1 is 1.5 amperes, resistance is 17. So we are just going to get the product, 25.5 volts. This is now the voltage drop across R2. Get the product of the current and the resistance, 18 volts. And do the same thing for R3. How much voltage is lost when the current passes through that? 1.5 times 11, that's the resistance, 16.5 volts. We have a way of finding out how much voltage, or if our calculated voltage drops is correct if we add all of them. They should be equal to the total voltage here provided by the battery, which is 60 volts. Okay, so if we add them, it should be very, very close to 60 volts. Okay, that's one of your clues, or one way you can check if you did the right calculation in series connections. Okay, here we have the same setup, but I suppose different givens. I am just going to provide the final answers, and I would be expecting that you would do the calculations in your notes. Here now, we are going to calculate for the equivalent resistance, or the total resistance, if my resistors are placed in parallel instead of in series. So here we have three resistors, R1, R2, and R3. 17 ohms in the first branch, 12 in the second, and 11 in the third branch. Okay, So we have this as our formula, and we are just going to put in the values here. 17 ohms, 12 ohms, and 11 ohms in the denominator. So you can you can put the fractional answer or you can put the decimal answer. Mm, the fractional answer would be 523 over 2,244, or in decimal, that's going to be 0.2331 over 1 ohm. That's not your final answer. You still have to reciprocate that. I reciprocated the decimal form of the answer, but you can also reciprocate this. So that's going to be 2244 divided by 523. And if I did that, I would get the total resistance of 4.29 ohms. What is the voltage drop across each resistors? So in parallel connections, the voltage drop across each branch is the same as the voltage gain from the battery. So that's just another way of saying that if your electrons would gain 60 volts from the battery, they would lose all of them. If they pass through the first branch, they would lose all 60 volts, or if they pass through the second or the third branch. That's why the voltage drops is the same as the voltage source. Okay, so this is our formula. You can see the equal signs here. So I'm already given with the total voltage, so I really don't need to calculate anything when asked for the voltage drop. And the resistors are in parallel. What is the current through each resistors? Okay, so I draw the current. How much current is passing through R1, R2, and R3? Okay, so remember that in parallel, the current are divided into your branches. So let's say the electrons are flowing from here to here, and then at this point, they would divide into the three branches, right? Here, here, and here. For I1, that's the current passing through R1, the voltage again is the same with the total voltage divided by 17. That's the resistance. So the current passing through that resistor is 3.52 or 53. For I2, I would use the same formula. 60 over 12, that's 5 amperes. And I3, that's again 60, same with the battery source, over 11, 5.45 amperes. So if I add all of this, it should be equal to the total current. What is the total current? Well, hindi mo pa na-compute. You haven't computed it yet. So total voltage over total resistance. We calculated the total resistance from a while ago. So the addition of these three, I1, I2, and I3 should be very, very near 14, around 14 amperes. Okay? Okay, so same setup, different values for resistances. Please calculate on your own, but I am showing the final answers, the values rather. Oh, this time we have a combination circuit. This is what we call a combination circuit. We have 5 resistors. Well, because here we have R3 and R4 that are in parallel, and then they are in series with R1, R2, and R5 outside of the branch. The voltage is 6 volts. I already told you how you can simplify combination circuits. The first thing to do is, here in this particular scenario, is to get rid of these parallel connections. So let's replace this with a single resistor. That's our formula. 1 over 12 plus 1 over 6. This is the decimal answer. Reciprocate the decimal answer. You're going to get 4 ohms. So this one here would be 4 ohms. Now we have all the resistors in series. we just have to add them, right, to get the total resistance. 16 ohms. Okay, so we got the total resistance. Now they are asking for the voltage drops and the current. We calculated for the current first. Remember that they are now in series, right? So that means that everywhere, everywhere here, would the current would be the same. It's the same current flowing through the circuit. So we just need to calculate for the I total. 60 over the total resistance, 18. So that's going to be 3.33 amperes. How much voltage is lost when it passed through R1? 3 ohms. You just get the product of the current and the resistance, 10 volts. On the second one, 20 volts. Here, on the combined, on the equivalent resistance, that's going to be 13.3 volts. And here on the last one, R5, 16.7 volts. So which one is, where did we lose the least amount of voltage? In the first resistor, because it's also the least resistance, right? The higher resistance, the more voltage drop you will get. Okay, so this is the same setup, but one less resistor. We only have four, but you still have parallel connections here, and they are in series with two resistors, R1 and R4. Oh, we are also solving it. Okay. 1 over 4 plus 1 over 4. That's the value of R3 and R4. The decimal answer is 0.5, 2 ohms. I guess the fractional answer is 1 half, right? If we reciprocate 1 half, that's 2 ohms. Get the voltage drop, but first the total resistance, it's going to be 10. Total current, voltage over resistance. 12 over 10, 1.2 amperes. Same thing here. You get the product of the current and the resistance. Okay, if we add the voltages, it should be equal to 12. That's all. Thank you, everyone.